Okay, so we are going to work on the second section of chapter 3, which is going to be more graphing of parabolas. Um, Specifically, we're just going to deal with two different methods that you're going to see the equations written in, because there's multiple ways they can be written in. So this particular section will have two learning targets. The first is that you can graph equations in standard form, which is you're also going to see standard written as like polynomial, which I have written below. They mean the same thing. Standard form, polynomial form. I'll probably use them interchangeably because I'll just use whatever pops in my head, which we'll talk about what that form looks like. Okay. And then you have an axis of symmetry is a line that divides the parabola into mirror images and passes through the vertex. We've actually kind of already talked about the axis of symmetry, but that being said, the axis of symmetry is always going to be super important. Notice that it says and passes through the vertex. Okay, this is very, very important and incredibly key to a lot of what we're going to be doing. The vertex, remember, is either the absolute highest point of our parabola if it's opening below, and it's the lowest point here if it's opening up. So you're going to need to know that the axis of symmetry, that vertex, is always, always, always on the axis of symmetry. So quadratic equations can be written in polynomial and or standard form. You're going to hear it said both ways. And that form is ax squared plus bx plus c, where a, b, and c are just going to be any real number that you've come accustomed to, and x will be our variable. Okay, and then lastly, when the graph of a quadratic has at least one x-intercept. Okay, what is an x-intercept? An x-intercept is where a graph will cross the x-axis, meaning the y value is 0. The function can be written in intercept form, okay, and that is y is equal to a times the quantity of x minus p times the quantity of x minus q, where p and q are going to be some numbers, and x will be our input variable, y will be our output variable. Okay, so that's just kind of some basics that you're going to need to have down. Otherwise, let's just kind of move on to just some of these things. Okay, so like our equations can be written in a bunch of different ways. And so we just figured it might be good practice for us to expand some of these polynomials, because this is currently in vertex form, which you have your a value, your h value, and your k value, which this all tells you very valuable information, right? It tells me that it has the vertex at -1, 4. It's going to open up. It's going to be thinner. Things of that nature. Okay. Well, we can kind of do the same. Ultimately what's going to happen is we can take this equation and we can convert it into polynomial form, which is this form. And from that, they'll be the exact same equation. So they can be represented differently. So let's just go ahead, and this will pay dividends really more in chapter 4. But let's just go ahead and get a little practice with this while we're at it, okay? So order of operations, if I want to expand this out, like your PEMDAS, right? Okay, PEMDAS. I want to deal with my parentheses first. So I look at x plus 1 inside the parentheses. I ask myself, is there anything I can expand out? Well, no, x plus 1 is simplified. Okay, but then I need the exponent. What about exponents? Is there exponents to deal with? Yes. Here, x plus 1 squared. Well, that's the same as x plus 1 times x plus 1. Okay, squaring means to multiply. Squaring means to multiply by itself. So that's why I have two x plus 1s here. X plus 1 times x plus 1 is x plus 1 squared. Okay, next we have multiplication and division. Well, there's no division in this problem, but there is multiplication. So I'm going to go ahead and I'm going to multiply 2 times this parentheses here. Okay, so I distribute here, and now I get 2x plus 2 times x plus 1, and then plus 4. Okay, there's still multiplication to be done here, right? Because I have 2x plus 2 times x plus 1, well, those need to be multiplied by each other. Okay, and so this is the first time you're going to see this, but if you would have taken Algebra 1 with me or any other teacher, it's common. You might have seen the box method, which I'm going to use the box method. Others may have used the FOIL method. And if you have used the FOIL method and that works for you, I encourage you to use it. I'm going to use the box method. Okay, so here we create a little box, and on one side we're going to go 2x plus 2. Okay, just like that, and then here I'm going to go x plus 1. So really this is just a nice way for us to reintroduce the box method, as well as just some other really basic concepts we haven't really dealt with for a little bit here. Okay, and so in each of these boxes, I just have to tell what each little part multiplied is. So here, if I want to figure out what's going to go in this box, I'm going to go x times 2x. Well, 2 times the sneaky 1 here is 2, and x times x is x squared. Okay, and then here, 2 times 1, because this is a 1x, right, is 2, but there's no x times x, so it's just x, so this is going to be 2x. Okay, so 2x times 1, well, anything times 1 is 2x. And then 2 times 1 is 2. Okay, and then if you look here in the diagonal, we actually have like terms here. 2x and 2x, what would that combine to? So if I combine 2x and 2x together, I would get 4x. So 2x plus 2 times x plus 1 is going to multiply into 2x squared plus 4x plus 2. Okay, so that's what this part is, but we don't want to forget about this plus 4 here. Okay, and then lastly, I need to do addition and subtraction, right? So I do have some addition, right? Well, the thing about like 2x squared and 4x is they cannot be combined together, because this x squared and this x are not like terms. If they were both x squareds, I could combine them, but they're not. I have an x squared and an x, so they're going to stay separate. Okay, and then we have a 2 and a 4, though. Those are like terms. There's no variables with them. So they're like terms, meaning that I can go plus 6. Okay, so if I wanted to rewrite g of x, it would be this. Okay, g of x is equal to 2x squared plus 4x plus 6. Okay, and it's pretty convenient because that these will represent the exact same graph. They're the exact same function. We're just rewriting it. So there will be times where you're going to look at, this one here, and realistically for graphing, this is going to probably be more convenient than this. But what we will learn is, like, as I mentioned here before in the previous section, I can tell that this graph starts at -1, 4 and opens up, right? I can look at this same one and I can tell different bits of information that we'll dive more into here in a little bit. Okay, lastly, let's just go ahead and find our a, b, and c value, because if you look at polynomial form, we have an a value, a b value, and a c value. So even though the instructions aren't telling us to do that, I think it's going to be beneficial. Let's find a, b, and c. So as I look here, we'll just do, I suppose I'll do a in black. So like a is going to be equal to the value multiplied by the x squared. Okay, so the value multiplied by the x squared here would be 2. Okay, so if I want the b value, okay, the b value is always going to be the value multiplied by the x. So this number here multiplied by the x here is 4. And then lastly, c is the constant value. This is just the number that is being added or subtracted off on the end if you write it in a, b, c polynomial form. So for me, it's 6. Okay, that is kind of it for the first one. I'm going to go ahead and do h of x because it has a fraction here and a negative number, and so that will really prepare you well for a, q of x, and then also f of x. Another quick reminder that g of x really isn't telling me to do anything. It means that this function here, its name is g, and its input variable is x. Meaning, if I wanted to know what the y value is when x is 5, that would just be g of 5, and whatever the value is would be the y value. Okay, so it really just functions as if it were the y variable. Okay, let's go ahead and move on to h of x. Okay, the process is going to be the same. Okay, this one I'll try to go a little bit quicker. Okay, inside the parentheses, there's nothing to do, so I'm going to move on to multiplication, or my exponent, and I know that x minus 5 squared is the same as x minus 5 times x minus 5. So I'm just going to kind of rewrite that down. Okay. Okay, and then next I need to multiply. Okay, now for this particular one, okay, we can distribute the negative 1/5. Okay, so if this was just a negative sign, like you might see here, this would be distributing negative 1. Okay, so here I'm going to distribute, so I get negative 1/5 x plus 1 times x minus 5. Okay, so this is me distributing. Okay, and then next I need to multiply these parts together. Okay, set up my box. I'm going to have negative 1/5 x, and then I'm going to have plus 1 here, and then x minus 5. Okay, ready? X times negative 1/5 x. Well, negative 1/5 times 1 is going to be negative 1/5, so that's going to stay the same. And then x times x is x squared. Okay, so this term here multiplied together is negative 1/5 squared. X times 1 is 1x, or x. X and 1x are the same thing. Okay, negative 1/5 x times negative 5. Well, this is pretty convenient, right? A fifth of 5 is 1. So we know this is going to be 1x. It's just a matter of whether it's going to be plus 1x or minus 1x, right? Because 1/5 of 5 is 1. But a negative times a negative is going to be a positive. So this is going to be a positive x. Okay, and lastly, 1 times negative 5 is negative 5. Okay, and again, I have like terms in the middle. So what's 1x and 1x going to combine to? 1x and 1x will combine into 2x's. Okay, so here I now have negative 1/5 x squared plus 2x minus 5, and then plus 2 kind of out on that outside here that we were missing. Negative 5 plus 2, well, there's 3 more negatives in this 5 than positives in this 2, meaning that there's going to be negative 3 left over when I added these together. Okay, and then again, let's find our a, b, and c value. My a value here is negative 1/5, number multiplied by the x squared. Notice that in my a, b, and c, I never have the variable. It's always just the coefficient or the constant. So try to remember that. Okay, b is the number multiplied by the x. So for me, that's 2. And then lastly, c is going to be negative 3. That's my constant. Okay, so good time for you all just to pause the video, go ahead and try q of x and then also f of x, and then you can check it with my work when you are done. Okay, so I'm assuming that you've already paused the video and you're here to check your work. I actually already did this in the background while the video was paused, just so I can walk you through it and we can get to the kind of the meat of the stuff that you're really going to need to know how. You're definitely going to need to know how to do this, but stuff like this necessarily will just be assumed that you know and not necessarily tested over. Okay, so I expanded x minus 2 squared into x minus 2 times x minus 2. Here's a little bit of a tricky part is I had to distribute a negative 1 here, right, because of this minus sign. This means multiplied by negative 1 or the opposite of, which are the same thing. So I have to distribute a negative 1 here. So negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. Okay, so after that, then I went ahead and multiplied negative x plus 2 times x minus 2. Negative x plus 2 times x minus 2. X times negative x is negative x squared. X times 2 is 2x. Negative x times negative 2 is positive 2x, because negative times a negative is a positive. And then negative 2 times positive 2 is negative 4. these will combine into 4. So here I get negative x squared plus 4x minus 4. And then plus 3, this 3 here that's been brought down. Then I combine here. There's one more negative in this 4 than there's positive in this 3, so this is negative 1. Okay, and then last, so this is my function. Q of x is right here. Q of x is right here, and the a value is negative 1, right? Again, kind of tricky. It's a sneaky negative 1 here. Just the negative sign indicates that I'm multiplying by negative 1. B value is 4, and then my c value here is negative 1. Okay, last one's basically the same thing, just has a fraction in it. Really doesn't make it that much harder. It's about the same. Okay, so I expand x plus 4 squared into x plus 4 times x plus 4. Okay, and then I distribute 3/4 x to each part. So 3/4 x plus 3, because 3/4 of 4 is 3. And then I set it up over here. Okay, so x times 3/4 x is 3/4 x squared. 3 times x is 3x. 3/4 x times 4 is 3x. Again, 3/4 of 4 is 3. So that's how I can do that in my head. 3 times 4 is 12. Okay, so then here, these combine into 6x. So I get 3/4 x squared plus 6x plus 12. Okay, and then again, this plus 2 that's being dragged along. Lastly, I add these to get 14, making my a value 3/4, my b value 6, and my c value 14. Okay, so now that we've kind of put that into a form that we can take it from one form to the other, what we're going to do now is we're going to graph those in polynomial form, standard form, same thing. So if I say standard form, I mean polynomial form. If I say polynomial form, I mean standard form. They're going to be the same. Okay, so we're going to graph each function below. We're going to label the axis of symmetry and the vertex. Then we're going to identify the domain and range. Okay, so I have the function 3x squared minus 6x plus 1. Okay, so when you're starting these problems, it's a little more difficult than the vertex form, because the vertex form gives you the vertex right away, and then you just get to jump right into it, because once you have the vertex, the work required is actually relatively easy. Where some of these other ones, it might not be the case. So let's go ahead and just start in with the axis of symmetry. Okay, the axis of symmetry, you're going to see me often abbreviate it like this, AOS, for axis of symmetry. Okay, and the axis of symmetry is that vertical dashed line. We've actually already done an axis of symmetry before. Okay, and it's very important because the vertex lies on the axis of symmetry. So the axis of symmetry follows a very, very distinct pattern, and it is always this. X is equal to the opposite of b divided by 2a. Okay, so once you figure that out, you're going to figure out what x value your axis of symmetry is going to go across. Okay, so let's go ahead and look at our function here. So this, let's identify my a value as 3, my b value as negative 6, and my c value as 1. Okay, and I can take a, b, and c right from there into this formula. Let's go ahead and do it. Okay, the opposite of b. So I want the opposite of b. Well, my b is negative 6. So the opposite of negative 6 here divided by 2 times a, which is 3. Okay, well, what is the opposite of negative 6? Okay, that is 6. 2 times 3 is 6. So this whole thing is equal to 1. It is an x is equal to 1 line. So we got to find the line that represents x is equal to 1. So on my x-axis, let's find x is equal to 1. Okay, and it's a vertical line through that. All my x values on this line are 1. Every single one of them. Okay. Okay, this is the x is equal to 1 line, and that is my axis of symmetry. That's the first place to start every single time. You shouldn't have to go ahead and do anything else. This is the place to start, okay? So I find my axis of symmetry here. And the next thing you're going to want to do is you're going to want to find the vertex, because the vertex always lies on this axis of symmetry. That highest or lowest point will fall on the axis of symmetry. So that's going to be finding the maximum or the minimum. Okay, so you're going to take this x value, x is equal to 1, and you're going to plug it into our original function that's on the top. So here, f of 1 is going to be equal to 3 times 1 squared minus 6 times 1 plus 1. Okay, and these ones I got from the axis of symmetry. Okay, we could go ahead and solve that out by hand. Hopefully my calculator has enough battery life. It's running dangerously low. Yeah, it just died there. Okay, 1 second. All right, luckily I had batteries. So, okay, let's go ahead and we're going to plug this function exactly into the calculator later and let that do all the work. So 3, and where I'm putting my x value, I want to put it in parentheses. Squared. So the squared button is, if you locate your second button and you scroll on down, you can see x squared. That's the button you're going to want to hit, and it will go ahead and pop up the squared button. Minus 6 times 1 plus 1. And that's negative 2. Okay, so I now know that f of 1 is equal to negative 2. That means when x is 1, y value is negative 2. Okay, so we can graph that ordered pair, right? So graphing that ordered pair, 1, negative 2, is going to be right here. Okay, so this is my vertex, okay? Now, here's the nice thing, is that a value in vertex form will function the exact same as the a value in standard form or polynomial form. It functions the same. A value in vertex form is going to tell me whether it opens up or down. Opens up when it's positive and opens down when it's negative. It will also impact the width, the wideness, or the narrowness, sure, of the parabola as well. If the absolute value of it's greater than 1, it's going to be narrower. If the absolute value of it is less than 1, it's going to be wider. So it's going to impact it the same. So even without the graph, I can actually answer the maximum or minimum question. My a value is 3. That's going to indicate to me that my graph is going to open up. And it's going to be pretty narrow. Okay, so if it's going to open up, that means I now have a minimum of negative 2 because I will have a lowest point. If you couldn't quite follow that, you will be able to see pretty obviously that this is going to be a minimum just by graphing the other points. Okay, so I went ahead, I graphed the axis of symmetry. That's in red. That's the first little blank here. Then I went ahead, found the vertex, which will be your maximum or your minimum. The next thing you want to do is you need to find other points on each side of the axis of symmetry. And you can do it the exact same way as we did in vertex form. There is one thing, though. There's almost a little shortcut for you. Let's go ahead and find the y-intercept. Okay. Let's go ahead and do that right now. We'll do it by hand, and then you're going to see a big trick. Okay, the y-intercept is when x is equal to 0, just like we did when we were graphing standard form of straight lines. When you find the x-intercept, y is 0. When you find the y-intercept, x is 0. So I can go ahead and find f of 0. Okay, so that means I'm going to take 3 times 0 squared minus 6 times 0, and then plus 1. Well, if we think about it, doesn't matter. 0 squared is 0 times 0 is 0. So this is just 0. Negative 6 times 0, that's just 0. So these are gone, completely gone. There's no value. It's 0. So what's left over? Just the 1, right? So here, f of 0 is equal to 1, right? Just this 1 here. Okay, so it's always just going to end up being whatever this value is, right? Because this is always going to cancel out to 0 because the y-intercept x is always 0. So this is kind of a shortcut, right? Because I have 0, 1, and then I can reflect it across to here. So I already have 2 points. So what is the shortcut? Okay, explicitly, the shortcut, the y-intercept is always 0, comma, the c value. Okay, you do not have to do this every time. As a matter of fact, I would probably actively tell you to avoid it because 0, comma c, so 0, comma 1, because my 1 is my c value. This is kind of the biggest convenience of this form. Kind of everything else is either the same or maybe a little extra work. Like vertex form, you don't have to do a whole lot of work to find the vertex or the axis of symmetry. This one, you have to do a little bit of work for that, but you do kind of get 2 free points, which isn't too bad. Okay, lastly, we need to find another pair because I want you to have 5. 5 if it fits on the graph. So let's go ahead and find the next one. So we already have x is 0 and x is 2. As well as x is 1, so I need to branch 2 away. Okay, so now I can pick x is 1, 2, 3, or x is negative 1. I'm going to pick x is negative 1. I don't really have any good place to do this, so I'm just going to kind of do it down below the range. So we're going to say f of negative 1 is equal to, and I picked negative 1 on purpose, so you guys can all see what it's going to look like when you plug a negative number in. Okay, it's going to be 3 times negative 1 in parentheses squared minus 6 times negative 1 in parentheses plus 1. Okay, and then I'll show you how to plug that into the calculator as well. I'll give you a few reminders. Okay, so let's go ahead and put this in. Okay, so I'm going to have 3 times, and then negative 1. I believe I've talked about this before. This is subtraction right here. But this little button right here is actually the negative number. So you're going to have to differentiate, like, when am I subtracting and when do I have a negative number, which can cause a little bit of a confusion, but it's not really bad. So here I'm going to go negative 1. Okay, and then this next part here, 1, notice you can see that this is negative 1, and then this is like a minus sign. The signs do look different. Okay, here I would be subtracting 6, and then I'm multiplying that by negative 1, and then adding 1. And then I get 4. So then I have the ordered pair negative 1, 4. So negative 1, 4. 1, 2, 3, 4. Okay, and then I can reflect that to my axis of symmetry and then away from my axis of symmetry. Okay, so okay, so I did make a little mistake here because I noticed that it formed a straight line here, and that's how I noticed it. So everybody just take a little look at my calculator and try to understand or figure out where my mistake was. Hopefully you identified that although I did multiply it by negative 1, I didn't square negative 1. So that threw it off. So let's go ahead and retype it. Negative 1 squared minus 6 times negative 1. Plus 1. Okay, so mistakes happen. Let's just use this as a learning experience. I try to just make sure you're plugging all of it in. I forgot to square it. Okay, and so this should be 7 or 10 is what I meant to say. Yeah, 10 because of, yep, negative 1 squared is 1 times 3 is 3 plus 6 is 9 plus 1 is 10. Okay, so then I actually have to go here and I'm just going to go ahead and put it straight up top here and then reflect it across. Okay, so important to note that these are not part of the graph. Those are mistakes. And notice this one grows way faster because that a value is 3. The further you get from 1, the faster it will grow. Okay, and then I'm just going to go ahead and try to connect it with as smooth of a curve as I humanly possibly can, knowing that more times than not it's not very good. Although, it's too bad I screwed up with those 2 dots because that was a pretty good curve. Okay, so that's what the graph looks like. Again, these x's are not supposed to be there. That was from my mistake, and rather that these are the correct. So 1, 2, 3, 4, 5 points is perfect. That's what kind of my expectation will be. Okay, let's go ahead and do the domain. If you recall, the domain is the list of x values you can use. Okay, list of x values you can use. So what are the x values I can use? Well, I kind of gave it away last time we had a lesson because I said you can use them all. Every single x value you're going to be able to use. No problem at all. So that means it is the set. This is the set symbol of x values. Straight line is going to be such that x is an element of the real number system, double bar R. Okay, so this literally reads the set of x values as long as x is a real number. If x is a real number, and we will learn about non-real numbers actually next chapter, which will be exciting, as long as x is a real number, you can use it. Okay, and you've heard of every number you've heard of before in the past is a real number, more than likely. And so this one, you can use any number that you're aware of to this point. Okay, the range is a little bit more difficult because remember, there's it's the y values you can get out given your domain. So my domain says I can use all my x values. So the range is saying, knowing that I can use every x value, what are all the y values I can get out? Okay, and if you recall, you cannot get all of them, right? Because there's no y value down here being used until I get to my vertex. And my vertex is that lowest or highest point. So in this situation, it's my minimum because this is the floor and it opens up. And it's a minimum of -2. So since my graph starts at -2 and goes up, that means my range is limited. My range is limited to the set of y values such that y is what? Well, y starts at -2 and it's all the values greater than that. So it's a set of y values as long as y is greater than or equal to -2. Because my graph starts at -2 and it's all greater than. All these y values on my graph are greater than. Okay, which is pretty good. All right, so I like these graphs a lot. They take a little bit of thought, but the domain and range requires a little bit of thinking, where a lot of the other stuff is actually pretty important to know the properties. These problems get a lot harder to remember how to graph if you don't know some of the properties. Like if you don't understand that this is a symmetrical figure, going to be hard to graph some of these. If you don't understand that the vertex is the lowest point or the highest point and that it's always on that symmetrical line, it's going to be hard to start. So these are the things that you need to know some of the background to be able to make the mathematics and the graphing part like doable. Okay, so before we begin, let's just look at b. B is p of x is equal to -2x squared minus 8x plus 1. So thinking ahead, I already know some basic properties. I know that it's going to open down, and it's going to be narrower than the standard parent function, which is y equals x squared. I also know it's going to go through the y-axis at +1. So think about those things. Those are the things that are really focused on in example 2. Those are the things that you should be thinking about before you even start, so you have a way to gauge how you are doing on as you're doing the work. Like, hey, mine's opening up. Why is mine opening up? My a value is negative, and then that can inform me or yourself on how you're doing, relatively speaking. Okay, pause the video and try letter B on your own and check it with me when you are done right now, which I've assumed that you've already gone ahead and done that. Okay, so the axis of symmetry is the opposite of B. The opposite of my B value is 8 over 2 times A, which is 2 times -2. So this is 8 over -4. 8 over -4 is -2. So this graph has an axis of symmetry at the x value -2. So I'm going to go ahead and do my best straight line on x is equal to -2. And I'm going to label that as the line it is, as well as AOS for axis of symmetry. And if you can, I would prefer it in a separate color, just so then we all collectively know that's not actually part of the graph. It's just a very important key feature. But if you don't have access to that, that's fine. Okay, so I know that my vertex is going to have the x value of -2 because the axis of symmetry lies on, or the vertex lies on the axis of symmetry. So I can go ahead and find out what p of -2 is. Okay, so I'm going to find out what p of -2 is, and I'm just going to do that by plugging in -2 wherever I see an x. So I'm just going to follow this equation up here. -2 times, well, x is -2 squared minus 8 times -2 plus 1. So that is 9. Okay, I know that since my a value is -2, and that I am going to have actually a maximum here of 9, because it's going to open down because my a value is negative. Okay, so let's go ahead and graph that ordered pair -2, 9. And that is right here. There's my vertex. Okay, next I need to do the y-intercept. The y-intercept is going to be right here. And it's always 0, comma, the c value. For me, my c value is 1. So my y-intercept is 1. 0, 1. And then once I have that, I can go ahead and reflect it across. So 1, 2 to my axis of symmetry and 1, 2 away. Okay. And then lastly, I need to go ahead and find a y value that goes with my x value. If you look here, I picked the x value on the axis of symmetry and then also units 2 away from the axis of symmetry. So that means I can actually pick an x value in between here. So I'm going to pick x is equal to -1. So I'm just going to do this right here. X is equal to -1. So that means I want to find what p of -1 is. Okay, and so then I can use my calculator, and again, instead of -2s, I'm going to replace them all with -1s. And hit enter. Oh, and I screwed up again. Classic. All right. Okay, so this is parentheses -1. There we go. 7. Now, even though most of you would have probably figured out that this was wrong because the number is so large, let's talk about how I know 7 seems more reasonable. Okay, 7 seems a little more reasonable because if I look at this ordered pair and this ordered pair, like I'm expecting my graph to go downward. So like if I had that this point was below this one, that means it would go down and then back up and then back down. That's not how these graphs work. I would expect it in a smooth curve to kind of open downward. Okay, so we can go ahead and connect these dots here the best we can. All right. And lastly, we just have to answer the domain and the range. Okay, the domain here is always all real numbers. Okay, every quadratic equation is going to be the domain is all real numbers. You can plug any x value. There's not going to be a hole or a graph or a break in our graph. The range does vary from function to function. So here you always want to look at your vertex. Again, it's up here at 9 is the y value, and all the y values associated with it are less than this value, right? There's none above it, meaning that the range for me is going to be the set of y values such that y is less than or equal to 9, right? Because it starts at 9 and all the y values are less than that. Okay, so that is standard form. Okay, not too bad, right? Here's the thing that's really nice about some of these functions is that since some of the properties are the same, really a lot of the work ends up being very, very similar. because the properties are the same, like reflecting across and finding this, that, and the other. But we do have one more form to go through, and this one here is going to be intercept form. Intercept form is the most important form when it comes to solving these algebraically. It's probably equally as important with the other forms as far as graphing goes, but as far as these ones go, they're pretty straightforward. But it's very important to solve these because there's going to be one concept that I'm going to talk about almost right off the bat, and it's very important. Okay, so let's just talk about the graph in general, not the parabola, like the graph you're working on. You need to know when I am on the x-axis. When I am on the x-axis, what is my y value? So think to yourself right now, because this is a very critically important question that and realistically, the answer to that's not overly complicated because it's always the same. But you're going to need to know this for next chapter. What is the y value when you are on the x-axis? So here's my x-axis here. And as I move up, like here's 1, here's 2. So if I just were to count down backwards of 1, 2, 2, 1, 0. Your y value is 0. This is incredibly important when it comes to solving these, but it's also going to be incredibly important to graphing intercept form because the x-intercepts, okay, the x-intercepts are going to be found out by these two parentheses, right? So we have a times x minus q times x minus p, and those are going to be your intercepts, okay? This is how you're going to find your x-intercepts. Your x-intercepts are going to be basically you're going to take each group and set equal to 0. And we'll think about why here in a minute. Let's just do the first one. Let's find the first x-intercept. Okay, I'm going to take x plus 3. That's going to be my first factor, and I'm going to set it equal to 0. You're going to take your first factor, you're going to set it equal to 0. So let's go ahead and solve. So we're going to subtract 3. So x is equal to negative 3. Okay, that's my first x-intercept. 1, 2, 3. X-intercept. There's my first ordered pair. Negative 3, 0. Let's talk about y. If I were to plug in x is equal to negative 3, so I take my equation, I go negative 2 times negative 3 plus 3 times negative 3 minus 1. What's this going to be? It's going to be 0, because what's the y value on the x-axis? 0. So why does this make it equal to 0? Well, if you look in this parentheses, negative 3 plus 3, what is negative 3 plus 3? Well, it's 0. So if I take any one of these factors, and I plug in an x value that makes it 0, so this is 0, and I multiply it by it doesn't matter what any of this other stuff is. If I'm multiplying it and one of these factors is 0, it's automatically 0. This concept is crazy important, especially in the next chapter. So I'm just introducing it to you now, but it would be awesome if you could have some of that figured out now as opposed to later. Let's go ahead and recap it. When I set the factor equal to 0, I get an x value, right? And my x value is negative 3. That is an x-intercept because it makes one factor 0. If one factor is 0, and when I multiply by all the other ones, it's going to be 0 automatically. So what is going to be the next one? Well, the next one, because there's going to be 2. More times than not, there's going to be 2. There is, you're going to take the other factor, x minus 1, and set it equal to 0. You're going to add 1, and you're going to get x is equal to 0. Not 0, 1, sorry. X is equal to 1, and that's right here. Okay, so there's my 2 intercepts. What do you notice about this 1 and this negative 3? hopefully you have identified that it's like the opposite of what's on the inside here, right? So this is x plus 3. My first intercept's -3. It's the opposite of +3. My other intercept is +1. That's the opposite of -1. And that is intentional. That's not a coincidence. That is how it works. Okay. So to find the axis of symmetry is actually pretty easy, because so instead of starting with the vertex on this one, we're starting with 2 outer points. So point here and point here. Where is that axis of symmetry going to be? It's going to be right in between them, dead center in between. So really, there's not even a whole lot of like number crunching or anything of that nature. We just get to go ahead and find the axis of symmetry. And it's just going to be always right in between. So it's, 1, 2, 3, 4. So it's going to be 2 units in. And that is my axis of symmetry. Okay, not a lot of math needed to be done there. This is x is equal to -1, which is my axis of symmetry. Okay. So I'll even put a little note for you. In between x-intercepts, and this would be x is equal to -1 for me. Okay, there is a formula for this that I'm going to show you. So our basic form for this is y is equal to a times x minus p times x minus q. Right? So p for me would be -3 and q for me would be +1. Okay? So you can just take these numbers and go p plus q over 2. So for me, that would be -3 plus 1 is -2 divided by 2 is -1. You can use this. I found it just a million times easier just to get your x-intercepts graphed and find the number in between. Okay, I do know I'm going to have a maximum number here, and how do I know this? I know this because my a value, again, is going to function the same across all 3 forms, and it's negative, so it's going to open down. So let's go ahead and find f of -1. How come -1? I know -1 because my axis of symmetry number is -1. And the vertex always, always, always is on the axis of symmetry. So here I can go 2, if I can load this up, 2 times -1 plus 3, parentheses, times -1 minus 1. Okay, and then this is a +8. So I have a maximum of 8. And that is going to be on my axis of symmetry. Okay, so we have now a unit 2 away, and the vertex, we just have to find one in between. So we can actually use 0, which is going to be nice, right? Because I could pick -2 or 0. So let's go ahead and we can do f of 0 here. I want to find f of 0. The function when x is 0 is all that means. So -2 times 0 plus 3 times 0 minus 1, which is 6. And then right across, and then we can go ahead and there's our curve. Okay, domain. Domain and range are always the same. So the domain here is the set of x values such that x is an element of the real number system. Okay, as long as x is a real number, you can use it. There's no holes or gaps in the graphs. Range, the approach to it's always the same, so I'm slightly misspoke. It's not always the same, but the approach is always the same. You look at this value, you say, hey, this is a maximum, so all my y values are less than that. And what number are they less than? It's 8. So we're going to say that this is the set of y values such that y is less than or equal to 8. Because the graph opens down, so all those values are less than. Okay, kind of the same. I mean, the concepts are all the same. It's just a matter of where you start, okay? And that can be a little bit confusing, but if you can really get down where to start on all of these, the rest fall into place pretty nice and neatly. So let's move on to C. I want to give you a reminder that on C, since you have a fraction out here, it's often helpful to try to pick units 4 units away from the axis of symmetry when you're picking those values. You're going to see that when I do the problem. Otherwise, for you all, I think it's great to pause the video, try this one on your own, and then check it with me, which is going to be right now. So I'm assuming that we've already tried this and you're here to see how you did. I'm going to find my x-intercepts first. The first way I'm going to do it is take my first factor, set it equal to 0, and then I'm going to add 6. Yeah, x is equal to 6. That is my first intercept. And then I need to find the other intercept, which would be x minus 2 is equal to 0. Okay. X is 2. Okay, so then the next thing I want to do is find the axis of symmetry, which is the number directly in between 2 and 6. So the number between 2 and 6 is 3, 4 would be 4. So my axis of symmetry is strictly just 4. Let's go ahead and graph that. Alrighty, trying to get a nice neat line here. Okay, so this is x is equal to 4, which is my axis of symmetry. Okay, that's what the graph looks like. Let's keep moving on. Okay, I know that this opens up because my a value is 1/4, which is a positive number, so it's going to be a minimum. And so what I need to do is I need to find what g of 4 is. Okay, g of 4 is just going to be me taking this equation and plugging x in for 4. So let's go ahead and do that here. Remember, when you're doing fractions, I feel most comfortable putting parentheses around them. So there's 1/4 times 4 minus 6 times 4 minus 2. And that is going to be negative 1. So when I go down here, I now have a minimum point. It's negative 1. Okay, and then let's go ahead and find this for negative 1, which will be right on that axis of symmetry. Okay, what I talked about before, I want to talk about again, right? So whenever my a value is a fraction, often it can be helpful to look at the denominator and say, if I want nice, neat points on my graph, I want to look for units like 4 away. So I could pick units 1 away, but more than likely I'm going to end up with some messy fraction or decimal that's going to be right here, where instead I can pick for units 4 away from my axis of symmetry, and then it's going to give me some nice, neat whole number. It might not be on the graph because sometimes they increase fast, but for the most part, the ones with fractions grow a little bit slower. Fractions less than 1 grow a little bit slower. They might be on the graph. So here we have the option of picking 1, 2, 3, 4. So we can pick 0, or we could pick 8. Again, for me, I like picking numbers that are smaller and easier to deal with. So I am going to go ahead and find what g of 0 is. Okay, so again, I'm just going to take this equation and I'm going to replace the 4's with 0 because those are my x values. And I get 3. So g of 0 is 3. So that means when x is 0, y is 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. All right, so this is a little bit wider one. I think this is a fantastic one to look at. Just in comparison to the one that we have here. Look how much faster this one shoots down than how much more gradual this one shoots up. Okay, and that is due to the a value. The a value here is 1/4. It's smaller. So every time you find these other values by plugging the x value in, you're making it smaller by multiplying it by 1/4. Where this one here, you're making the value smaller by multiplying and making it 1/4. Right here, you're going to multiply your numbers and you multiply it by -2. That is going to increase the value. Although the number's getting lower because it's -2, but it just makes it steeper nearly, and this will make it more gradual. Okay. Lastly, let's go ahead. Our domain is going to be the same thing always, which is the set of x values such that x is an element of the real number system. And then the range is going to be the set of y values such that, well, let's look at the graph. Well, here, if I look, this minimum value here, it starts at -1. It starts at -1, and all the y values here are greater than that. So it's going to be greater than or equal to -1. Okay. Well, here, I'll let you look at that for a little bit longer. Okay. All right. That is the graph, and that is the section. Okay, so there are 3 different methods: vertex, standard, / polynomial, same thing, and intercept form. And they all have their different benefits. So hopefully you all took a moment to go ahead and see what those benefits were. Okay. Otherwise, now's a good time just to move on to the homework, and then I will see you all in the next section, 3.2.